Welcome to my presentation. In this presentation, we shall see examples on operations with limits. So let us take an example. In this example, we want to find the limit, the value of this limit, when this limit is given to us as the limit x to the power of 2 minus 4, the whole thing divided by x minus 2 as x approaches 2. So in here, we will break it down. The way we want to solve it is we want to break it down into these different steps. As step number 1, we're going to write it out in this manner. We know the following things: a squared, the special forms of polynomial. We know some basic rules. The special forms of polynomials, as when we have a squared minus b squared, we can write this one as a plus b times a minus b. So in the numerator part of the limit, we have x to the power of 2 minus 4, we can write as 2 to the power of 2. So 2 to the power of 2 is 4. So it is very similar to the special form of this polynomial. So we can write this one as x plus 2 times x minus 2. So we can write the numerator part of the given function like that, and therefore I'm going to rewrite the given function limit of the numerator part of the function. I can write it as x plus 2 times x minus 2, the whole thing divided by x minus 2 as x approaches 2. So now the things which are common in the numerator and denominator are x minus 2, so therefore I can cancel them out, and then therefore the given problem simplifies to limit as x approaches 2 to this function x plus 2, like that. And therefore now, as we'll call this as step 2, and when we simplify this step 2, we can now start to substitute the value of x, or we can also write it this way: limit of the first part of the function, which is x, as x approaches 2, plus the limit of the second part of the equation, which is 2, as x approaches 2. So when we simplify this, limit of x as x approaches 2, we're going to substitute the value of x as equal to 2, and the limit of the constant number 2 is going to be equal to 2, and therefore the value is going to be equal to 4. So therefore the limit of a function which has x to the power of 2 minus 4 divided by x minus 2 as x approaches 2 is going to be equal to positive 4. Let us look at another example here, and in here we're going to have a trinomial in the numerator. Find the limit for this particular function. Limit of x to the power of 2 minus 6x plus 9, this whole thing divided by x minus 3, like that. And then when as x approaches 3, that is the question we have. So to solve this problem, we're going to break it down into these different steps, and we're going to write this one out as follows. If we were to look at the numerator part, I'm going to take it on the side here: x to the power of 2 minus 6x plus 9. If we can use the perfect square method. If the first term is a perfect square, we want to recognize if the first term is a perfect square, it is. Is the last term a perfect square? Yes, it is. 3 raised to the power of 2. So we can write the base term for the first term, which is x. We can borrow the sign for between the first and the second term, which is a negative sign. We can take the base term from the third term here, and then write it as 3, and when we can put open close parenthesis and then raise it to the power of 2, therefore that is going to be the value, or the factorization process for this particular trinomial. So x squared minus 6x plus 9 we can simplify as x minus 3, the whole thing raised to the power of 2. So instead of the numerator, I can come back and then write it as in its factored form as x minus 3 raised to the power of 2. I can also write this x minus 3 raised to the power of 2 as x minus 3 times x minus 3, same thing, right? So therefore, I'm going to rewrite this given expression, the limit of the numerator part. Now I can write it as x minus 3 times x minus 3 divided by x minus 3 as x approaches 3. Now, as we can see, in the numerator and in the denominator, we have common terms. X minus 3 and x minus 3 is common, so we struck out one of them, and therefore this simplifies. We'll write the second step as the limit of this expression x minus 3 as x approaches 3. So we can now write it out as individual limits and then find the value of that limit. So as step 3, I'm going to break it down into limit of the first function, which is x as x approaches 3, minus the limit of the second part of the function, which is 3, as x approaches 3. In here, we can now start to substitute the values of x as equal to 3 in this fourth step. In the first part of the expression, limit of the function x as x approaches 3, we're going to substitute the value of x as equal to 3, and then minus the limit of a constant number is going to be equal to the same number, therefore 3 minus 3, and that is going to simplify to 0. So therefore we had a polynomial expression in the numerator and in the numerator. So when we simplified it using the perfect square method, we factored it as x minus 3 raised to the power of 2, and then we saw that we had common terms in the numerator and common terms in the numerator and denominator, so we canceled them out, and then we applied the rules, or applied the operations of limits, and then separated these limits out and then simplified it, and then the value came out as equal to 0. This is the way we're going to solve problems using operations with limits. In my next presentation, we shall see more examples with operations of limits.